Recent advances in science and technology, with a significant impact on economic development, have been possible only with the support of electronic technology. These span the most diverse fields, such as communication, transportation, space, education, and agriculture. Electronics is at the very core, either driving industry or improving productivity, or making possible things which were hitherto inconceivable. The importance of electronics in national development was well recognized by CSIR as early as 1953, when the foundation of the Central Electronics Engineering Research Institute was laid at Pilani by late Pandit Jawaharlal Nehru, our first Prime Minister. The institute started functioning in 1957. Over 4 decades, CEERI has been concentrating its efforts on research and development, which are directly relevant to the needs of the industry and of the country. Current activities at CEERI cover 3 major areas. These are microelectronics, strategic electronics, and industrial electronics. Industrial problems are tackled to facilitate the transition from the traditional to the modern. Sugar and associated pulp and paper industries are the largest organized industries in rural India, with a turnover of several thousand crores of rupees. Microprocessor and PC-based electronic systems have been developed at CEERI with the objective of improving productivity, quality, and saving of energy. An automatic pH control system, MAPCON, has been developed for the juice purification processes in the sugar industry. This has 3 control loops to regulate lime and sulfur dioxide through motorized valves with online monitoring of 3 pH values. MIPMOS is a pan monitoring system. It helps to reduce the total boiling time and the consumption of water and steam by as much as 20%. MicroTimac is a 16-loop digital temperature monitoring and control system. It provides continuous measurement and control of temperature. The system has helped to reduce overall energy consumption by more than 10%, which in turn has resulted in higher productivity of sugar. These systems have been manufactured and installed by CEERI collaborators in 100 sugar factories. CEERI is now expanding its sphere of activities to include a few more process stages in sugar plants and is using a distributed process control based on PCs with color graphic display facilities. Indigenous Local Area Network, LAN, has been developed for the process control applications. For boiler controls, a flue gas oxygen analyzer has been developed. Transportation electronics has been another thrust area at CEERI. An electronic excitation control system for diesel-electric locomotives developed at CEERI is in production by the industry. More than 1,500 locomotives are running with these systems, manufactured by ECIL and BHEL, based on CEERI know-how. CEERI has also developed a 150 kVA single-phase to 3-phase thyristor converter to replace the Arno converter in the WAM-4 electric locomotive. The system has been successfully field-tried by the Indian Railways. In strategic and critical applications for defense and communications, microwave tubes play a key role. CEERI is a leading organization in the country devoted to this area. CEERI has developed pulsed magnetrons of different frequencies and power level and tunable multi-cavity klystrons, giving more than 1 kilowatt of continuous wave power. Technical know-how for these devices have been transferred to Central Electronics Limited and to Bharat Electronics Limited. The traveling wave tube plays a key role in communication through satellites. A 6 GHz, 20-watt traveling wave tube has been developed and tested for over 12,000 hours at ISRO's Earth stations at Ahmedabad and Delhi. Research and development work on traveling wave tubes has now entered a new phase involving high power and broadband traveling wave tubes. A 30-watt S-band traveling wave tube has been developed as a grant-in-aid project for Bharat Electronics Limited, Bangalore. Development work on miniature gain and phase-match traveling wave tubes has recently been undertaken under sponsorship from users. Other areas of development are miniature fast warm-up K-band pulsed magnetron, 2 megawatt S-band magnetrons, and 5 megawatt S-band klystron. Special purpose high current density dispenser cathodes have been developed under the sponsorship of the Department of Electronics. Such know-how is not available from outside agencies. CEERI has also established a competent base in computer-aided design of microwave tubes. Computer-aided design software developed for microwave tubes has been supplied to agencies abroad on a commercial basis. Consultancy is being provided to Bharat Electronics Limited, Bangalore for redesigning different traveling wave tubes based on the computer-aided design packages. Another thrust area of CEERI is that of microelectronics. Over the years, the Institute has established one of the most outstanding infrastructures for research and development in this area. Facilities established at CEERI are housed in ultra-clean rooms and include some of the most advanced tools of research. These include computer-aided design and testing, mask making, diffusion, ion implantation, low pressure as well as plasma-enhanced chemical vapor deposition, reactive ion etching, metallization, and scanning electron microscope facility. Monolithic integration involves putting several thousand components on a silicon chip. CEERI has set up a VLSI design center for application-specific integrated circuits called ASICs for industrial applications. Typical examples of application-specific integrated circuits developed in the Institute are 8-bit counter, microchip for 32-line electronic telephone exchange, signal processing chips for PWM AC motor drive, microwave oven controller chip, and serial data communication controller chip. Examples of power semiconductor devices developed in the Institute are silicon-controlled rectifiers, junction transistors, Darlington power transistors, which combines two transistors on the same chip, permit higher switching speed and do not require commutation. The 100 ampere, 400 volt monolithic power Darlington transistor, along with the freewheeling diode developed at CEERI and packed at Bharat Heavy Electricals Limited, is under field trials. 300 ampere, 400 volt Darlington power transistor has also been developed for AC motor drive applications. Fast switching thyristors of 1700 volts, 1300 ampere rating developed at CEERI are under production at Bharat Heavy Electricals Limited, Bangalore. Neutron dosimeter is a silicon diode with thick base for high neutron sensitivity. CEERI has indigenously designed these devices, which is now developed and produced by Meltron, saving considerable foreign exchange. Impact diode devices generate power at micro and millimeter wave frequencies. Development program on these devices was initiated at CEERI under the sponsorship of DRDL, Hyderabad. Class 100 clean rooms were built using in-house expertise to house fabrication and characterization laboratory facilities. More than 200 of these devices of 100 GHz, 10 watts performance characteristics have been delivered to the user agency. Research and development works on high-temperature superconductors has been initiated as a part of the national effort. Transitions have been observed up to 27 degrees Celsius. Laser beams have been tried out for deposition and removal of superconducting layers. Thin films up to 0.6 micrometers of bismuth compound have been deposited by a novel technique of spin-on coating. Josephson junction and squids operating at liquid nitrogen temperature have also been fabricated. Hybrid microcircuits, which combine active as well as passive electronic devices and integrated circuits on a single substrate of ceramic material, help in shrinking the large size of printed boards and are more reliable. CEERI has facilities and expertise for design, development, and fabrication of hybrid microcircuits for meeting the stringent requirement of space applications. Hybrid microcircuits for Indian satellites such as SROS and INSAT have been developed and fabricated at CEERI. 3 different types of hybrid microcircuits have been integrated in INSAT-2 satellite, which is now in space. Mini Circuits Limited, Bangalore, and GCEL of Baroda are in regular production of these hybrid microcircuits based on CEERI know-how. To bring the benefits of research and development to the doorsteps of the users and industry, CEERI has set up 2 centers, one at Delhi and the other at Madras. The speaker identification and verification system assumes great importance since more crimes are now being committed through networks. CEERI Center New Delhi has undertaken research and development in this area through interaction with users. Database on 400 words has been prepared. A speech synthesizer has been designed and developed. The system has been interfaced with word recognition system to give voice output. Man-machine communications. Another area where CEERI centers have used voice commands to make an equipment operate. Know-how has been transferred to users on voice-operated machines. A speech secrecy system using low bit rates digital data communication has been developed at the center. This system has been field tried by the Indian Railways. The center has also developed a 32-line electronic telephone exchange, which is being commercially produced by 6 licensees. A number of systems for non-formal education and teaching aids has been developed for the user agencies. These include information retrieval and interactive displays for trade fairs, museums, and for the National Literacy Mission. The National Literacy Mission has also entrusted the task of design, development, and delivery of electronic hardware and software to CEERI. These include 100-watt and 150-watt convertible power packs for solar-based operation and chargeable power packs for use in 2,000 JSN centers in the villages. The paper and pulp industry is undoubtedly one of our priority industries which is based on our own raw materials and needs immediate modernization. At CEERI Center Madras, microprocessor and PC-based systems for online measurement of basis weight, moisture, and caliper have been developed. This integrated equipment, involving special O-frame and display system called ScanPack, has been installed for field trials in a commercial paper factory in Tamil Nadu. This center in Madras has now been transformed into a center of excellence for modernization of the pulp and paper industry. The center has also developed special instruments for other industries, such as the food packaging industry. In pursuance of its technological development program, CEERI has undertaken several challenging tasks. In the last 4 decades, it has been a source of know-how for our electronics industry on a number of products and processes. Altogether, this institute has completed 70 sponsored projects and received more than 14 crore rupees from various sponsoring agencies. The products manufactured by industries based on CEERI know-how has resulted in a turnover of over 130 crore rupees. The institute has demonstrated its proven capability as a pathfinder and pace-setter in the field of electronics in India. Over the years, its capabilities have grown considerably, both in terms of expertise and facilities. CEERI's achievements have contributed significantly towards import substitution and self-reliance. With increasing emphasis being put on electronics in the country, CEERI looks forward to play an important role in assisting our electronic industries towards faster economic growth in this area of high technology.